Hello and welcome to my video, lesson 1.2, surface area of pyramids. So 1.2 obviously has more than just pyramids, but we're going to look at pyramids in this video. And so if we look here, we have a blank pyramid. I'm just going to label two things that you would commonly be given. You could also be given a third thing, and I will tell you about it in a second, but then you would need Pythagoras Theorem, which I will mention to you in a second. So here we have the two things that would be normally given are the base. Okay, so this edge here is the base, and often it'll be a square base where both sides are the same. So this will also be base, but it also could be that the other side is different, where this side is maybe just a different side, different size. Okay, but let's first talk about it as a square base pyramid. All right, so let's talk about a square base, which means that this side and this side are both equal. So that's the base. The other thing that you might be given would be the slant height, which would be from the tip, the apex up here, all the way down to the center of one of the edges of the base. So we call that the slant height, or we'll just put an H there. Last thing that is possibly given to you is the actual height, which is from the dead center at the bottom middle, going straight up to the apex. And that would just be the regular height. So one is slant height, one is regular height. So we'll just use little h to denote regular height. Let's put that to the side. There you go. So regular h to denote regular height. So if we're given the purple and the red, we can very easily find out the surface area of this pyramid. We can just think about it again as the sum of, or the addition of, all the sides together. So the easiest one is just the bottom. Okay, the red, I'll try to shade it in here. The red square here at the bottom is really easy to figure out because any square is just length times width, and in this case it's base times base, right? It's the same thing, multiplying together by itself. Ooh, my computer's heating up here. So in that case, it's really, really simple. So let's put some numbers together here. Maybe our base is 5, and our purple height here is 4. All right. So if that's the case, then base times base is going to give us. Let's just write down this. Let's write this down right here. So base times base plus, and then we'll go through in a second here. And so then we can also write down 4 times base, which is 5 up here, times height, which is another 4, and divided by 2. All right, so just something to notice here is even before we even wrote this down, we can actually simplify in this step. So let's do that right away, and then we'll go back to that. There's a 4 and there's a 2. So what's 4 divided by 2? Well, it's actually just 2. So we can actually simplify this whole equation to base times base plus 2 times base times height. If we have a square pyramid, that's very important. If we have a square pyramid, then we can write it out like this. Okay, so let's rewrite this part. 2 times 5 times 4. And now we just multiply. So 5 times 5 is 25. Let's do 4 times 5 is 20. So 2 times 20 is 40. So we're left with 40 here. And then, oops, sorry about that. Whoa, yikes. My computer's being a pain here. I need to change the batteries in my pen. So we have now 65. 65. So yeah, that's the most common and kind of the most basic form of this. One thing to note again is, what if we have one of these bases as a different number? So maybe that one's 5 and the other one's 3 or whatever. Then our equation has to turn out to be different. So in that case, surface area would be A times B plus BH plus AH. So you just have to then go through and be very careful to do all of your sides. So this is the square bottom. This is 2 of your triangles. This is another 2 of your triangles. So as long as you're going through and counting up all the different sides and adding them up, then it will work out every time. Okay, what if you're given the green H, just the actual height of our pyramid? Well, we're going to notice something here. If we're given the height of our pyramid, it's going to make a little bit of a triangle inside. So the height here and the half of, stick with red here. Half of this is the distance here. So that's the half mark that I'm talking about. And now we can use something called Pythagoras Theorem. So Pythagoras Theorem tells us that if we have a triangle with a right angle, whoops, that's not a very good triangle. Let's try it again. If we have a triangle with a right angle, then A, B, and C are the sides. Then C squared equals A squared plus B squared. So we can actually find out any of the other sides if we just use the other equal sides. So the most common form of this is if we have 3 and 4 for these two sides. Well, then we'd have 3 times 3 is 9. 4 times 4 is 16. And then we can add those together to get 25. So C squared equals 25. Now, opposite of exponents is square roots. So square root of 2, square root is opposite of exponent to the 2. So we're going to square root 25. And would you look at that? C equals 5. So if you draw this out and measure it, and you'll actually find out that this is true, that if we have one side of 5, 3, 4 each, then that will make a triangle. So anyways, if you're given, let's say, the green height of 3 and the base is 8, then you can figure out the opposite, or whatever's missing, you can always find the opposite. Generally speaking, we'll stay with these more simplistic versions of this, but I wanted to let you know about Pythagoras Theorem and just remind you of it from grade 9. I hope this video helps you guys, and good luck.